Yeah, okay. So let's say we have x raised to 4 plus 6x squared plus 9. And every time, see, we will be using those three identities that I discussed in the last class. Those three identities are, can you guys tell me what is a plus b whole square, then a minus b whole square, and what is a plus b times a minus b?
I think a plus b times a minus b is a squared minus b squared.
Mm-hmm.
I think a
Sean,
minus, yeah.
Sean, do you remember?
Not exactly.
Okay, fine. Yes, Pavna, so you remember?
I might, yeah, I think so. So I think for a plus b whole squared, it's a squared plus 2ab plus b squared. And then for a minus b whole squared, it's a squared minus 2ab minus b squared? Or is it
I
plus b
think
squared? Okay.
no, I
Plus.
think it's still plus b squared. Yeah.
Yeah. The only sign will change for the 2ab term. Plus b square will remain same. Okay, so okay, one thing, when you're going from left to right, I mean when I'm writing this expression and then you're telling me this expression, so this is basically called expanding. You are expanding this binomial expression. When you're going from this side to this side, you are expanding this expression. But if you go from this side to this side, then you're doing factoring. So you have this polynomial, let's say you have a square plus 2ab plus b square, this is a polynomial. And when you're writing it like this, you're making its factors. So a plus b is a factor of this polynomial. For this one, you have two factors. A plus b is a factor and a minus b is also a factor. So this is what we'll use. These three formulas we'll be using to factorize this expression. Okay. As the topic says, factor using quadratic pattern. So I will make some substitution. You guys must be remembering this. I will create this. This is right now, this is quartic expression. I will do substitution. I will substitute x squared by any other variable, let's say u. So that means x squared is u. So what will be the value of x raised to 4? If x squared is u, so x raised to 4
U
will
squared.
be u squared. So we will do this substitution. So in place of x raised to 4, we'll write u squared, and this will become 6u plus 9. So we have successfully converted this quartic equation into quadratic equation. And now comes this formula into picture. If you look at this formula carefully, I see this u is nothing but u squared. This 9 is 3 squared. I can write 9 as 3 squared. Now just compare this expression with this expression. If you compare it with this expression, can you tell me what is the value of a and what is the value of b?
A is 1, B is 3, and then, yeah.
No, a is u. In
A is
place,
U, so technically it's
yes.
like, yeah, A is U, but it's
In place
like
of
the
a,
coefficient is 1.
no, not coefficient. If I want to find out what is the value of a, in place of a we have u, and
Okay,
in place of b we have 3.
yeah, so then 2 times
Oh,
3 is 6 times U is 6U.
Yes, so we'll write 2 times a. In place of a I will write u, and in place of b I will write 3, because we just found out that a is u and b is 3. Now I can write it in the factored form like this: u plus 3 whole square, because value of a is u and value of b is 3. So I have made its factors, and now you need to put back value of u. U was x squared. So put back the value of u, which was x squared. So it is x squared plus 3 whole square. So your final answer. So the factors of this expression, I'm changing the color. So your original expression was x raised to 4 plus 6x squared plus 9. So its factors are x square plus 3 whole square. Basically, this factor is repeated, x square plus 3 and again x square plus 3. If you multiply these two factors, you will get this expression. Is this clear? You can just look at the steps one more time.
Yeah, I get it.
Okay. All right. Now let's do one more problem. Do you want to note it down?
I took a picture.
Oh yeah, can you just give me a second, 1 second?
So this factor x square plus 3 cannot be factorized further. This is the maximum level of factorization that we can do. Okay, Sean, are you done?
Oh yeah, I have a question. So do we now just set it to 0 to fully factorize, or is that what factor is?
No, if you want to solve this equation, no, right now this is just an expression. If you
Okay,
had,
solve it, just set it to 0.
yes, if you had to solve
Oh,
a quartic equation, so for instance, what we did, this was an equation when it was equal to 0. Okay, then you would set it equal to 0, the final expression. So
okay, thank you.
this is not an equation, this is just an expression. Okay, next let's do one more problem. X raised to 4, this one, in this one there will be one more extra step, 13x squared plus 36. Okay, so let's do the substitution. So if I'm just writing it directly, I will get u square minus 13u plus 36. I have done the substitution. X square has been replaced, or x square has been substituted by u. Okay. Can you try to tell me the factors for it?
I think it's u plus 6 squared, or
Okay.
technically x
Okay.
squared plus 6. Wait, no, that doesn't.
But
Yeah,
okay,
x squared
one thing
plus.
I want to focus upon, when we wrote it like this, 9 was written as 3 square, and we wrote this term 2 times u times 3. Then just verify it once. Is 2 times 3 times u will give you 6u or not?
Okay.
2 times 3 is 6, and 6 times u is giving us 6u. Okay, so here this works perfectly fine. But here, Bhavna, if you compare it with that method, I'm just writing it, a minus b whole square is a square minus 2ab plus b square. So if we compare it, this can be written as u square, 36 can be written as 6 square. So that means value of a is u and value of b is 6. So if I write it like this, I will get u square minus 2 times a is u and b is 6. So now if you multiply 2 and 6, you will get 12. But here you have negative 13u. So this will give you u square minus 12u plus 36. This is not the same expression. So here this formula will not work. I hope you understood this point, Bhavna and Sean.
Yeah.
So always verify if you're getting this term or not. So here we will go with splitting the middle term method. The AC method or splitting the middle term. Find out the factors of 36. Remember 36, factors of 36. 9 and 4 will work. Negative 9 and negative 4. Negative 9 and negative 4. So this can be written as negative 9u minus 4u. plus 36. Factor out u, you'll get u minus 9. Factor out negative 4, you'll get u minus 9. And we'll get factor out u minus 9, we'll get u minus 4. This till here it's clear?
Yeah.
Sean?
Yep.
Okay, now put the value of u back to it. U was x squared, right? Put it back. So x squared minus 9 and x squared minus 4. Now it may look like these are the final factors, but you can further factorize these factors. And now we'll use the third formula. A square minus b square is a plus b times a minus b. So this is x squared. 9 can be written as 3 squared. This is x squared, and 4 can be written as 2 squared. So I will apply this formula. For this, for the first factor, a is x and b is 3. So I can write it as x plus 3 and x minus 3. And for the second factor, I can write it as x plus 2 and x minus 2. Any questions in this step?
We can factor it further, right?
Again, can you factorize these factors?
No, never mind. Never mind. Yeah, I get what I mistaken it because I thought, for x plus 2, x minus 2, we could do the but that would be like making it into a equation again. Never mind.
Yeah. No, that will give you this factor, x squared minus 4 again. So these are now linear factors. Okay. We will always try to factorize till the point we are getting linear factors. But here we cannot factorize these two further. This one can be factorized to quadratic factors. These are quadratic factors. These are, and the next question you have linear factors. So this expression can be factorized into these 4 factors. If you multiply them, if you multiply these, see, basically we are doing opposite of multiplication. All that we have done is we have done opposite of multiplication. Now if you multiply them, you will reach to this expression from where we started. I hope it is making sense.